I just want to zoom out and go back through memory lane. So if you think about week 1 with circle geometry, we did all the theorems that deal with the circle and the center of a circle. So the line from center perpendicular to a chord, a line from center to the midpoint of a chord, and then the really important one, the angle at the center is twice the angle at the circumference. So those all had the center of a circle involved in the theorems, and that's why I grouped them together. Then we also had the fact that the diameter makes an angle of 90 degrees, or angles in a semicircle. So that was another idea that we explored. And then we also looked at how equal chords subtend equal angles, both at the circumference and at the center. So give me a thumbs up if that looks familiar to you as facts or theorems that you need to be aware of. Give me a thumbs up if that's looking familiar to you. Okay, awesome, awesome, awesome. And then last week, we went to what's called the cyclic quadrilateral theorems, or cyclic quadrilateral facts. And what we focused on in the last lesson was sometimes what they call the butterfly theorem, or angles in the same segment. And we said, for example, this angle is the same as that angle, and this angle down here is the same as that angle. And then the theorem before that, we discussed how opposite angles of a cyclic quad add up to 180, and how the exterior angle of a cyclic quad is the same as the interior opposite. We also spoke about what makes a quadrilateral cyclic, and that is that the 4 points of the quadrilateral are on the circumference of the circle. So give me a thumbs up if that looks familiar to you. Okay, I see the thumbs of the people. Okay, so now what is today going to be about? So today, and I'm going to show you some visualizations, but the 3 main ideas that deal with, well, the main idea that we're going to focus on today is something called a tangent. And a tangent is a line that touches a circle in only one place. Now, it's possible to have dual tangents like this last one here, where they basically come tangents from the same point, but we're really going to focus on tangents. And so just to give you a quick little summary, if you've got a radius and it meets the point of tangency, that will always make a 90-degree angle. So a tangent and a radius meeting each other will always make a right angle. And I'll show you this in a visual, but it's called the tan radius theorem, or tan perpendicular to radius. I've also seen it written like this, tan radius theorem. So that's the one theorem we'll look at. Then there's something called the tan chord, and that is that the angle between a tangent and a chord. Oh, let me try that again. The angle between a tangent and a chord in a circle, so that's the angle between the tangent and the chord in a circle, is equal to the tangent in the other segment. Or basically, if you take that chord and you base your angle that you're subtending on that chord, then these two are equal. And so this is sometimes called the windsurfer theorem. But it also works from the other side. So if you go the angle between the tangent and the chord here, that's going to be equal to the angle over here. So this is called the tan chord theorem, or sometimes called the windsurfer theorem, because it looks a bit like the windsurfer. And then the last one about tangents that we need to have some awareness of is that if you have 2 tangents meeting at a point, then the length from the point of tangency will be equal. So we'll be saying basically the blue is equal to the pink. So if you have a tangent from a common point, then it basically forms an isosceles triangle. Now, it's probably a little bit too many words all up front, but I'm going to come back to the tangents in a moment. But let's just do a little bit of revision of a question that we did. Something, we're not even dealing with tangents first. Let's try and solve this problem. And what you have to do is you have to find me the size of angle Z, the size of angle Y, the size of angle W, and the size of angle X. And I would love us to help each other. So I want us to give each other hints. So where would you start? Which angle would you go after first to solve? I open it to the class. Where should we go, people? Which one do you think is the easiest to gobble up first? Ask yourself, what theorems or facts can you remember from the first part of the lesson that might be helpful here? Okay, so some students are saying going after why. So Sanako and Naledi, why were you going after why? What is your reason or thinking? Maybe share your thinking in the chat or pop your mic on and just let us hear. What is your thinking about going for why? I've only seen why so far. So most students seem to want to go for why. What theorem are we going to use to find why? Who has some ideas for us? Opposite angles of a cyclic quad. Okay, almost. Here's the sneaky thing, guys. Can you see this point over here? Is that point on the circumference? No, that's the center of the circle. So the problem is, to use the cyclic quad theorem, you need to have 4 points on the circumference. So I was also feeling quite drawn to the y, but then I remembered, actually, I think the w will be the easiest one to get first. Yes, so I was going to go for the w first. So who can tell me, what do you think the w is? Because I feel like the w has a relationship with the yellow 137. Who can tell me? Pop your hand. I'd love to hear a student voice. Just pop it up and just tell me, what idea or fact can we use? Ooh, Buchler, 43. I think you know what's going on here. So I think this thing is a cyclic quad. And so because it's a cyclic quad, opposite angles in a cyclic quad add up to 180. So we say W is 180 minus 137, which is 43. And the reason is opposite angles cyclic quad. So we know that this is 43. Now, what should we go after next? Now I was thinking, let's go after y. What do we think y is going to be? And I want us to share our thinking. Even if we're wrong, it doesn't matter because we're going to learn something. So who has an idea? How can I connect y to w? Or how can I, what relationship might there be there? Cullen, I know you want to help us. Great, I know you want to help us. Tell us your thinking. Help your classmates here. Okay, Buchler has said, angle at center is twice the angle at the circumference. So I think what Buchler is thinking is that if I imagine this arc here, it is going to make an angle here, and it's also going to make an angle there. Or what we say is the angle at the center is twice the angle at the circumference. And so we would then say this is 2 times 43 or 86. And that is, how do I write it? It is angle at center equals twice angle at circumference, or the arrowhead. Okay, what do we go after next? What do you think we should get next? Cullen, I agree with you. That is awesome. Gundo, I think you want to help us out. Where would you go next? Would you go X or would you go Z? Gemma, what are you thinking? Manila, who has some ideas here? Go after Z. Okay, Naledi, help us out. What do you think Z is? What do you think Z is going to be? Okay, I see a hand up there. Let's go to Bukle. Bukle, what do you think Z is going to be?
So by Y and Z, I see some. It looks like it's a ribbon, and there's
Okay.
a theorem that's show like I don't know what the theorem is, but
Yes.
Z is going to be half of 86. That I know for sure.
Yeah. Okay. So what you're using is the angle at the center is double the size of the angle at the circumference. So if you're looking at the relationship between Y and Z, it would definitely be 43. Or what you could do is you could use the butterfly theorem, and I'll show you now how you do that. Can you see that you could go up here and then you could also go over there? And so what you then see is there's a relationship between this one and that one. So you have a choice. You could either say angle at the center is twice the angle at the circumference, or you could say angles in same segment and say that this is 43. It's almost like these are both in the same butterfly. Okay, now there's only one thing left to get, which is x. What is x going to be? What is x going to
Sorry, sir.
be? Hey, who's speaking? Is that
Um,
Bukle or is it someone else?
yes, sir. It's me.
Okay.
When sir says angles in the same segment, I don't see the two angles joined by the same chord.
Okay, but that you could, okay, you're right. So there is no chord, but there is an arc. You could imagine the chord being like this. Can you see the chord there between R and
Oh,
S? So
oh,
if you
so we
see
are allowed to
that,
construct.
yeah. But you can also think of it as being constructed on the arc between R and S. And then it's
Oh, I
going
see
up
it.
to here. Sorry, I'm being a bit messy. It looks a bit like a party or something in here, or maybe a crime scene. But anyway, um, but you get the basic idea there. Now, what about
Yes, sir.
x? How are we going to find what x is? Well, I think that everything must add up to 360. So we just go 360 minus 86, and that is just going to be a revolution angle. And we would say then you take away 60, 26. I get 274 degrees, which is actually double the 137. Now, I want to know from you, out of 10, how well did you understand that question? So 10 is perfect, 0 is nothing, 5 is the middle. You need to let me know in the chat how well you could follow that question so I know if I can move on or not. QSTR is also a concyclic. QTS. Oh, yes, well spotted. Yes. Well done, Callan. So Callan has actually spotted that I could have got Z by just going, this is a cyclic quad down here. So this thing over here is a cyclic quad. And so you could have also said, well, these two add up to 180. Very nice. Very, very nice. Okay. I think I'm not going to go into tangents quite yet. I think we need to do another one like this to practice, and then I'll go on to tangents in the second half of the lesson. Okay, so let's have a look at this question over here. Oh, let's do this one. So we're practicing, and it says here in the figure, O is the center of the circle with PT equal to TR. So PT is equal to PT is equal to PR, sorry. So those two are equal, the green and the, then it says express X in terms of Y. Express X. Now, where is X? X is up here. Now, that's interesting. Okay. Who has some ideas of how we can get the Y to move around a bit? Because we have to get a relationship between X and Y. So I'm going to give you a moment to look at the drawing. Where would you start if you wanted to express, if you wanted to somehow get the Y moving around and connect it to X eventually? Just give me a hint first. Because we know that there's the y sitting down here, and we have to connect it somehow up to, we have to connect it up there. Can anybody see an isosceles triangle here? Give me a thumbs up if you see the isosceles triangle. Can you guys see the isosceles triangle? Now, if I have isosceles triangle, I think that this one over here has to be y. So we can say that angle PTR is equal to y. And the reason is angles opposite equal sides. Now, I'm getting warmer. If I get a y and a y there, where I want to get them closer to the x, I want to connect these guys up to x. Where do you think I would go next? Remember, I'm trying to get them to get all the way up to x. Who has an idea for me? Is it possible to get this one or to get this one over here? So I think there's a theorem that says there's two ways. One way you can do it is say, this is 180 minus 2y, therefore this is 2y. Or you could have gone straight to 2y with the exterior angle of the triangle theorem. So you could have said exterior angle of a triangle, like literally the exterior angle will always be the sum of the interior opposites. Or you could have said sum of angles in a triangle is 180 minus 2y. Angles on a straight line mean that that's 2y. Okay, now, how do we connect up the 2y and the x? What is the relationship? I think that this is an angle at the center, and this is an angle at the circumference. So how much bigger is the yellow one than the pink 2y? Oh, that's too light. Let me rather use a different. How much bigger is the yellow one than the blue one? Okay, the angle at the center is twice the angle at the circumference. So x is the big one, 2y is the small one. If we want to make them equal, I will have to double the small one. So then x will be equal to 4y. Now that was actually quite a tough one, but I think I'll go over it for you. So step one was to say this and this is y. Then you could say 180 minus 2y. Then this would be 2y. And then you connect these two together. And I should also say, for the reason here, angle at center equals twice angle at circumference. Okay, Bukle, is that your hand up there? Is that? Oh, sorry, did I unmute? Let me unmute you again. What was your question?
I wanted to ask, so it says P1 is equal to 2y, exterior angles of a triangle. How is it an exterior angle? I think I missed that.
Okay, so I will draw this bit. Okay, it's not the perfect drawing. Can you see how I've pulled the triangle out here with a y and a y? It's just not a very good drawing. So can you see that this line, which extends up here, is actually the exterior angle of this triangle? And then the two interior opposites are here and here.
Oh.
But you don't have to do it like that. I think for a lot of students, maybe the better way to do it is to say, this is 180 minus 2y, and so therefore this is 2y, because it's angles on a straight line.
Oh,
does that
okay.
make more sense?
Oh, so by the way, exterior angles is the sum of the two interior angles of a triangle.
Yeah, yeah.
Okay.
All right, I'm going to stop there for now. I will put more practice questions like this in the Google Classroom for you to practice, but I do want to, just before the break, just give you a little introduction to the theorems about tangents for tonight. So the very first theorem, the tan radius theorem that you need to be aware of, and I just wanted to show it to you, is look at this as I move the tangent around the circle. What do you notice about the angle between the radius and the tangent? And you can put it in your, you can put it in the chat, or you can read your voice. What do you notice about the angle between the radius and the tangent? It stays the same. Yep, it stays the same. So we can use this as a fact or theorem to help us on the journey. Okay. Then the other one that I mentioned earlier in the lesson, which is tangents from a common point. So we have this common point out here. Now watch this. Look at how I move the common point around. But what do you notice about the distance between the common point and the point of tangency? Okay, so if you have, and this is often kind of how it's seen, if you have a circle and then you have tangents from a common point, so basically you're going to get this effect. So remember, a tangent is a point that touches the circle only one place. These will always be equal. These two sides will always be equal, and they'll give you an isosceles triangle that can be helpful. And this is called tangents from a common point. And then the last one, I don't want to, well, I can just, let me just mention it, but we will, we're going to practice some of the stuff now, is sometimes called the windsurfer theorem. And let me move, let's see if I can move anything here. I'm going to move the sail around the circle. What do you notice about the red angles, and what do you notice about the green angles? So I guess all of these are kind of, let's see if I move this, what happens here? Oh, I can even move this around too. Sorry, I'm having too much fun here. But what you notice is the angle between the tangent and the chord is equal to the angle subtended in the other segment. And so normally it looks a bit more like this, like a windsurfer, like this angle. So this angle over here is equal to that angle over there, and vice versa. So this is called the tan chord theorem, which we're going to practice in the second half. But let's start with this multiple choice question. I want to know, the sketch shows EB, the diameter, and ABC, the tangent to the circle. So we've got the diameter, and then we've got a tangent. If DBC, now where is DBC? If DBC is 72, then what is D plus EBD? So D, where is D? D is up here. And EBD is here. So this is the last one we're going to do before the break. So the black dot is the EBD. The D is the green dot. And DBC is 72. Which of the four options do you think is correct for green plus black dot? Yeah, Bukle, what is your question?
I think so, because it is on a straight line.
Yeah.
We can just say 180 minus 72, and then that will give us 108.
Yeah, I haven't worked out the answer yet, but I was just thinking, do you know what the angle between the blue and the green is going to be? Would you agree that it's 90? because this
Yes,
is
it's
goes to
perpendicular.
the middle. So I know that the black dot here, or EBD, will be equal to 18, and that will be because of the tan radius theorem. Basically, we know that will be 90, so therefore this must be 18, or 90 minus 72. Now, do we know what the green one is? The green one, if this is a diameter, oh, let me get this. If this is a diameter, what does the green one have to be? Or angle D? Well, it's an angle in a semicircle, so that would be 90. And that would be angle in semicircle. So then I want everyone to vote now. What do they think the correct answer is going to be? Is it going to be A, B, C, or D? But remember, it's asking you what is angle D plus angle EBD? What is the green plus the black? Well, I think it's going to be 18 plus 90, which is 108, which is this one over here. Because remember, the question is asking us what is D plus EBD. So what is green plus black? Green was 90. So green was 90 up here. And black was 18. So I think I caught quite a few of you there. So we're going to practice more of these in the second half. But that was just an introduction to how we can start to use the tan theorems. But we're going to practice more after the break. But you know what time it is. It's time for some brain breaks. So everyone, turn your cameras on. I want you to join me in standing up because you've worked hard. And we're just going to start with some deep breaths. So breathe in. Breathe in. One more breath. Breathe in. And then I want you to shake your arms around. So just a quick shake. Shake of this. Shake of your legs. Shake of your other leg. And then let's put our arms out. Some quick circles. So quick circles going forward. Quick circles going back. And then just roll your shoulders. And then roll your shoulders forward. And then just shake it out one more time. Okay, so got some oxygen, you've loosened up any of the stress in your body, and then the last thing, you know what's going to come, it's going to be 10 jumping jacks, just 10 today, taking it easy on you guys. Start in 3, 2, 1, let's go. 2, 3, 4, 8, 9, 10. And today's very friendly workout, speed workout, is over. And then your little puzzle question for today, I think you're going to like it, is I add 5 to 9 and get 2. The answer is correct, but how? Who can answer that riddle for us? Who feels like they have the insight to the riddle? Oh, my neck just clicked. Did you hear it? Where did I get the 18? Okay, I'll come back in a moment, Samsung, to that question. Has anybody got an idea? How can I add 5 to 9 and get 2? Almost, Naledi, almost. I'll give you a hint. Sorry, that's not the best. No. Give you one final chance, then I must move on. I add 5 to 9 and get 2. Okay. So if you are at 9 o'clock and you add 5 to 9 o'clock, you get to 2 o'clock in the morning. Watch this. 10, 11, 12, 1, 2. And so this bit, you go from 9 and you add 5. So plus 5, and you get to 2 o'clock. So that is the riddle. I know, it's a good one, isn't it? I enjoyed that. And so did you. I know you did. I know you did. I need to find some more good riddles like that. Okay, back to the maths. So the question was from Samsung. Sorry, I can't see the name in the profile. Is how did I get 18? And the way I got 18 was this. I know that this diameter, right? So there's a center of the circle. This angle from the new theorem that I've just told you about is 90, right? So this thing is 90, but it also told me that DBC is 72. So this angle, just the red dot here, is 72. So then this one over here has to be 18 to get to 90 in total. Does that help? Let me know, Samsung. All right. Let's do this first one over here, number 1. I want to know what is the value of angle A. You are given a tangent ABC. You are given a tangent ABC. I want to know what is the value of A. What is the value of A going to be? I'll give you some time to work on that. What is the value of angle A going to be? Let's have a look. Yeah, has a hand. Okay. So, Bukle, what do you think? What would you suggest? How would you approach this problem?
I think I would just go straight to, because we have our reason, OBC is
Yeah.
90 degrees because of tan radius.
Yeah.
And then we can just use the interior angles of a triangle. So we could say 180 minus 90 minus 5a, because we add 4a and
Yes.
a, which gives us
So
5a.
yeah, or even I'm trying to think. So I agree. So even I would just say A plus 4A must equal 90. Would you
Yes,
agree with this? Sum of angles in a triangle. So basically, if this is 90, these two together have to give me 90. And where would you go from there?
we'd add them, we get 5a is equal to 90, and then we'd divide both sides with 5. So then a is equal to 18.
Yeah. So A is 18, and then 4A would be 4 times 18, which would be 72. And that would make so much sense because 72 plus 18 is 90, and then together it's 180.
180, yes, sir.
Give me a score out of 10, people of the class, about how well you understood that number 1. I just want to see how much time I must give you. So give me a score out of 10 about how well you understood that first one. It helps me decide on what speed to go. Okay. Keep those votes coming, ladies and gents. Okay, let's do. Okay, let's do number 2. But what I want is I want us to first identify what theorem do we think, or what value should we try and get first? So should we go after X, or should we go after Y, or should we go after Z first? I want people to tell me which one I should go after first. Okay, now, if we go after X, what relationship would we use for X? So, oh, Dylan said Y. Okay, so there's some X's and some Y's. Which one would you go after first? I'm interested to know what the class says. So far, we have X and Y. I want a few more votes. Even if you're wrong, I want you to commit. Everyone needs to vote. So Gemma, Njabulo, Numuko, Mfundo, Pila, Samsung, Sanako, Tenda, let's get those votes in there. Which one do you think we should go for first? I think, okay, a lot of people are saying X. So I'm going to go with X for now. What relationship am I going to use to find X? Maybe somebody can just turn the mic on and tell me, what relationship would I use to get X? Or what fact or theorem would I use? What fact or theorem should I use? No, Sanako, it can be you. It can be you. Come on, Sanako, I know you want to help us. What relationship? Come on, come on, someone. Honestly, guys, I don't know tan radius. So I don't know if the X would be helpful there, though. I was going to go after the Y. So I was with Dylan on this one. In that I was thinking, aren't these both radii? So, basically, aren't these both from the center of the circle? So what should Y be? What should Y be? If this is 50 and these are equal, so Callan, I'm asking, what I actually think if someone can tell me what to do to go after X, I would go after it. But I don't see any relationship that I can use for X. But I do see something I can use for Y. So who can help me find a value for Y? Okay. All right. So let's go to Bukle. What do you think, Bukle?
Hi, I thought let me just unmute since they say obviously I'm
No.
going to unmute.
Yeah.
Um,
Go for it.
I think we would, because those two sides are equal, which means
Yes.
that other side is also going to be y,
Yeah.
the other one.
And Dylan
That's
agrees
going
with
to
you.
be
So
y.
if I look at the chat here, Dylan has said go 180 minus 50, then divide by 2. And then Callan has
Yeah.
said, can't we just do the sum of triangles? So you guys are all saying the same thing. So if I do that, and then I divide by 2, I would get 65.
Yes, sir.
Okay. So let's go with 65. Perfect. Now, I would like Naledi to help me with Z. Naledi, I want to know, what do you think Z is? What do you think Z is? Pop your mic on there, Naledi, and you can help us out. Sanako, same thing. Aren't we going to use the angles on a straight line? You can't here. So what you need to do is you need to show tangent. This thing over here is a tangent. I know it doesn't look like it, but those ones over there are a tangent. So now I want to know, what theorem do you think you know about that could help you? You know this bit is 65. So what the do you think what do you think the Z has to be? So I'll give you this hint. OBC. Oh, there we go. Callan's helping us out here. So OBC is 90. So then, Nomfundo, exactly. You're going to say this is tan radius. And then Nomfundo has said 90 minus 65. So Z must be 25 degrees. Perfect. So this is going to be 25 degrees. Now, Sanako, it's your time to shine. Help me figure out what value for X is going to be in the end here. It is your time to shine. Help us out here. What things can we connect up? Okay. All right. So I'll give you a hint, Sanok. If you look at these two together, the green one's on 90. And if I look at this one over here, this one is 50. So if that's 90 and that's 50, then what are we going to get?
Can't you say,
go for it.
can't we say 180 minus 65 minus 50?
Yeah, so 180 minus 65 minus 25 minus 50. Because remember,
it's sum of a
what are you going to get in total?
I got 60. I got 65.
Okay, but
minus
remember,
25.
you must take away another
40.
25. Yeah, so you're going to get 40. Yeah, so this is going to be 40. Thanks, man. Awesome. Okay, now, let's have a little vote. And I want everyone to participate because it really makes a big difference, guys. The more people get involved, the more the lesson will feel like a group thing together. And we all want lots of participation, but we want to make sure that everybody is participating. Okay, so let us go to question number 3. I want to hear what is going to be the value of E. So I want you to try and figure out what the value of E is going to be. But in order to do that, you're probably going to have to figure out what E, well, let's try and do it. See if you can figure out what E is and what C is. Dylan, I'm so happy. See, this is what's nice about doing it live, right? So we can interact and you can ask questions, and the more questions and insight you give me, the more I can adapt my program. So I really do want you to take that freedom and use it. Okay, and let's also just make sure I want to make sure the comments are friendly comments. Like I can't read tone through the comments, but let's also always be polite, friendly, and respectful in our comments. I don't want to feel like there's any antagonistic comments, okay? Because everyone is trying their best here, and yeah, I just want to make sure we keep it in that space. All right, so if we look at Callan, I like what I'm seeing there. So we know 5E plus E is 90. And the reason is going to be the tan radius theorem. What is the value of E going to be now? Well, we know that 6E is equal to 90. So if I divide both sides by 6, E will be equal to 15 degrees. Now, If E is 15, I want to know what is the angle C going to be. That's quite a hard one, actually. And I want some ideas in the chat. What facts can we use? Okay, I think, so we're running out of time here. So let me, oh, my pen just went off. So can everybody see the radii? Can everybody see the radii? Well, if you know that 5e, so 5 times 15 is 75. So we know that this angle down here is going to be 75. But because this is here is 75, then what C is going to be 180 minus 75, which is 30. And so the angle C here is going to be 30 because these two are equal. Now, what I would like to know in the chat is how would you score yourself out of 10 for basic understanding of the tangent theorems? I want to do one more, then we're going to call it a night for today. But how would you score yourself on understanding the basic tangent theorems? Okay, and the lady says 8, Cullen says 8. Okay, Peter, we're going to keep working at it. Remember, there's another lesson on Wednesday. So this is just our warm-up lesson today. Kwenda, Nomfundo, thank you for your votes. Dylan, fantastic. Okay. So you know what it is, Bukle, is I'm building up slowly. The problem is, and we're going to do harder questions in the next lesson, is I'm really trying to build a good foundation. And that's why you're feeling so comfortable. Okay, last question for today. I want to know what is angle F going to be? And then after you've found angle F, oh, flip. Sorry, guys, having a moment. Angle F, after you've found angle F, I also want to know what G is. So I open it to the chat. Again, remember, you're quite welcome to just put your hand up and your voice is quicker, but I know some people feel more comfortable than others, but it really is, it's lovely to hear voices. And so I do appreciate it when people do put their hands up and just share a little bit. Okay, but otherwise, chat, I can always read things from the chat. What do we think, what theorem is going to be involved with finding F? So there is a common point. It's ringing a few, yep, tangents from a common point. So there's a tangent that goes here and a tangent that goes here. And so what we're going to see is that those two are equal. So what does that make F? So you're quite right. AB and BC are equal. That's perfect. So now the question becomes, what is F? Now, because we're running out of time, I'm actually going to speed this up a little bit. But really, I want to say that these two are the same. And so we're going to go 180 minus 80 divided by 2. And so that is going to be 50 degrees each. So this will be 50 and this will be 50. Now, we now have to figure out what is G going to be. So last question of the day, what is G going to be? Put your answers in the chat. Oh, Sanako, let's go to you. Sanako, what do you think G is going to be?
So can't we say that G is 40?
Ah, yes. So did you see, Sanako, did you see the tan radius theorem here? Is that how you knew that one was 40?
Yes, sir.
Okay. And then how did you get from this 40 to G?
On the sides equal.
Okay, what are they called?
Isosceles, isn't it isosceles triangle, sir?
They're all isosceles or radii. So basically these two will be equal. So that's why that had to be 40. And if you really had to work out, you could work out that this would be 100. Because you know, but you didn't have to do that. All right, everyone. I think, give me a final score for today's lesson out of